Okay, how are we doing, everybody? So this is section 13.2, angles of rotation. All right, let's get into it. Okay, so when we're looking at trigonometric values, it's always based on angles, right? Angles. So we're going to take a little sidestep and talk about angles when they rotate across an axis or around an axis, I guess I should say. Oh, let me get that out of my way. In lesson 13.1, we investigated trigonometric functions by using acute angles and right triangles. Now, trigonometric ratios don't always just apply to acute angles and right triangles, so we've got to think about them in other quadrants, basically bigger, obtuse angles and maybe angles that even grow past 180 degrees and so forth. An angle's in standard position when its vertex is at the origin and one ray is on the positive x-axis. So when I talk about this thing called standard position, and that's how we're always going to set up our angles when they are in standard position. Standard position just basically means that the vertex of the angle happens at the origin. Okay. Now, one of the rays is going to be on the positive x-axis, so that right there. Okay, so if I was to say open up a 45-degree angle, that would be how it would look in 45 degrees in standard position. Okay, the initial side is on the positive x-axis. The terminal side is where the ray opens up to, with the other ray that it opens up that angle to. A couple examples here. I can have positive rotation. I can have negative rotation if I wanted to. So if I was going to say do an angle of 135 degrees, the initial side is on the positive x-axis here. And then it opens up to 135 degrees. So 45 degrees past 90, there's my terminal side. So this angle, all in total, is my 135-degree angle. I can have a negative rotation going down into the fourth quadrant here, going in the counterclockwise direction. Oh, excuse me. This is counterclockwise. This is clockwise, right? Going in the clockwise direction. Okay. Now, an angle of rotation is formed by rotating the terminal side and keeping the initial side in place. If the terminal side is rotated counterclockwise, that's funny. If the terminal side is rotated counterclockwise, the angle is positive. If the terminal side is rotated clockwise, the angle of rotation is negative. Terminal side can be rotated more than 360 degrees. Okay, I can actually rotate as an infinite amount of degrees. Maybe I can rotate it, 400 degrees or 500 degrees or 700 degrees or 8 million degrees if I really wanted to. So this is an angle 360 plus 30. So it looks like 30 degrees, but it's actually 390 degrees. It goes way past. 360-degree rotation is a complete rotation. 180 is one halfway round. So draw an angle with the given measure in standard position. So start off with a ray on the positive x-axis, and then I open it up 320 degrees. So think about it. Now, you're going to see me drawing these little spirals here. Past this section, I'm not going to be doing that anymore. So this is, think about it. Open it up, 90, 180, 270. Now, how much past 270? I'm not going to go all the way to 360. How much past 270 am I going to go? I'm going to go 50 degrees past 270. Just estimate it. Sure, somewhere in there. Okay, a little bit past halfway. So that angle is positive 320 degrees. Okay, let's try another one. Negative 110 degrees. So here's my initial side, negative direction, negative 90. And then how much more? 20 degrees. There we go. There's my angle. Okay. Again, you're going to see me draw in these little directional arrows there just for this section alone. Let's talk about 820 degrees. Okay, so this is 360, 720, 90. Okay, so we're here. So we're at 810 so far. 820. Right, here's my initial side. Here's my terminal side. Oops, my arrow there. Okay. So again, how did I figure that out? Well, this was 360, add another 360, 720, and then add in just a little bit more, 720, add in 90 more. That gets us 810, 10 more, 820. Okay, so it's 10 degrees past the vertical 90. Okay, negative 585. You see it down here. So let's draw on my initial side. Now my negative 360 degrees here. So how much more do I have to go? Well, let's think about it. That would be 585. I've already gone 360. So I need to go 225 degrees more. Okay, so here's 180. Here's 180 degrees more in the negative direction. And I needed to go a total of 225. So I need to go 45 more. Halfway into this quadrant. Okay. Again, you're going to see me stop drawing in those spirals pretty soon here. Now, why am I drawing in those spirals? Well, because you don't see the full rotation if you're just given, like, think about this angle. Okay, think about this angle. Right. Trying to be careful there. If I just open up that angle, what does that angle really look like? That angle looks like something completely different. It looks like, I don't know, 100 degrees, right? But this is really 820 degrees. So how do we tell the difference between 820 and 100 degrees? Well, it all depends on how much it actually opened up, because 100 and 820 are called coterminal angles. Coterminal angles are angles in standard position with the same terminal side. For example, 120 degrees and negative 240 degrees are coterminal. Take a look. Don't they land at the same spot? If I were to open up in the positive direction, 120 degrees, it'd be right there. If I were to go negative 240 degrees, this would be negative 80, and 60 more degrees would be landed right in the exact same spot. Okay. Now, there are infinite amount of coterminal angles. Why? Because, well, think about the angle measure. It'll be 480. 480. Let's do 480 real quick. Okay, so this would be 360. 480 would be 120 more. Oh, it's landing at the exact same spot again. What if I were to go 360 more? What if I were to go to 360 more, and 360 more, and 360 more? I could keep doing that forever and ever. So I could actually have an infinite amount of coterminal angles, both positive and negative. Find the measure of a positive angle and a negative angle that are coterminal. Well, to find the positive angle, I'm just going to add 360 degrees to this. Okay, so 425 degrees, right? Because 65 plus 360 is going to get me 425. Now, I just keep going back in the other direction to find the negative coterminal angle. I'm just going to take a full negative rotation off of it. 65 minus 360 degrees is going to get us, what was that? Negative 295. Negative 295. So there's my negative coterminal angle and my positive coterminal angle. Okay. Let's do a couple more. 410. Okay, now my positive coterminal angle, I actually just need to, since this is more than 360 degrees, I'm just going to take off 360 degrees, 50 degrees. The positive coterminal angle. I just want a positive version of it. If you add 360 degrees, well, what would that be? What is 410? 410 plus 360, that's 770, right? So you could say 770 if you really wanted to here, but 50 is a little cleaner. Okay, so let's take 50, and then I'm going to subtract away 360, negative 310. That would be a negative coterminal angle. So those are the two coterminal angles, positive 50 and negative 310. Let's do one more. Okay, so I'm already given a negative angle. To find a positive coterminal angle, let's just add 360 to it. So we're at 120, that's negative, and then I'm going to add 360, 240. 240 degrees. So that's a positive coterminal angle. Let's go another negative angle. So we'll go more in the negative direction. We've got 120 that's negative. And then I'm going to subtract another 360 from it to get negative 480. So there and there. There's my positive version. There's my negative version of the coterminal angle. Now, let's talk about reference angles. Reference angles are going to come up, are going to be a big topic here pretty soon. We start looking at the unit circle because we're going to have to identify what the reference angle is for any given theta. For an angle theta in standard position, the reference angle is the positive acute angle that's formed by the terminal side of theta and the x-axis. So say I had, and this basically says we're going to use them a lot more. Say I had this angle. I don't know what it is, maybe 110 degrees, 20 degrees past 90. What would the reference angle be? Well, the reference angle is always made with the x-axis and the terminal side. So if it lands in quadrant 2, like this one does here, this is going to be my reference angle. Okay, call it alpha, call it whatever, right? Doesn't matter. But that's going to be my reference angle. If my angle falls in the first quadrant, my theta is actually my reference angle, right? Because this is the acute angle. It's always acute and it's always positive. This is the angle that ends up being my reference angle. Okay. Say it lands in the third quadrant. Say here is my theta, right? Here's my initial side. Here is my terminal side. Well, then my reference angle would be this in here, okay? And we would just call it positive, okay? We would just call it positive. That's my reference angle. If the angle falls in the fourth quadrant, okay, say it was a negative rotation or something like that, this would be my reference angle, okay, right in there, whatever that measurement is. And then you just kind of have to like logically reason it through. What would the degree measure be there? Okay, so take 135, for example. Let's draw out 135 and see what happens. So here is my initial side. Here is my terminal side. Well, let's see where it opens up to. Here's 90, and we got to go how much more past 90? 45 degrees past 90, so halfway through there. Okay, so it lands in quadrant 2. This is my reference angle. We've got to figure out what this angle is in there. Okay, so I'm going to use the notation with theta too. You'll see why in section 13.3. So theta is going to be, okay, how do we figure this out? This is going to be, if I went to a full 180, I've got to take away 135 to figure out what that angle measurement would be. You just got to use your kind of geometry skills here. This is a 180 degrees, take away 135 and give me my leftover angle there. So theta is going to be 180 minus 135, which is 45 degrees. So my reference angle would be 45 degrees. You'll see why we're calculating reference angles in section 13.3, I promise. Okay, let's do another one. Okay, negative 105 degrees. All right, let's draw out what negative 105 degrees is. Here's my terminal side. So here's negative 90. Negative 105 is right here. Okay, so my reference angle is, since it lands in the third quadrant, my reference angle is here. Okay, so let's reason it through. What is that reference angle? Well, this is 105 degrees of rotation in the negative direction, but it's still a 105 worth of degree rotation. So this would be a negative 180 degree rotation, right? Full way all the way to the other side of the x-axis, right? So what I'm going to do is I'm going to take 180 and I'm going to subtract away 105. That's going to give me this leftover measurement right there, which is 75 degrees. Okay. And that's my reference angle. Call that theta, call it whatever you want. There's my reference angle. One last one here. So we're looking at 325. Okay. Let's draw it out. So here's my angle, or my initial side, 325. Here's 90, here's 180, here's 270. What's 325 minus 270? I'm going to go 55 degrees in there. 5 degrees worth of rotation right there. Okay, so here is my angle that I'm looking for. Okay, now think about this. What's a full rotation? 360 degrees. So I just want to take away that 325 to see what's left over. So 360 minus 325. A lot of people try to say, like, what's my set rules for finding the reference angle given what domain it's in? No set rules. Just logically, geometrically reason it out. Okay, so I take 360. Well, I've got a lot of calculators open here. Get those away. Let's take 360 minus 325, and that gives me 35 degrees. Now, another way to reason that through, didn't I just calculate that this was that 55 degrees left over that I had to rotate? What's 55 minus 90? Or, excuse me, the other way around, 90 minus 55. 35 degrees. Okay. All right. Now, if I wanted to, oh, sorry, what am I doing? Oh my gosh. There we go. Yikes, what the heck am I doing? Okay. So if I wanted to determine if I could basically give you any coordinate in space out there, and you could figure out the trig values for the reference angle, okay? And again, you're going to see in section 13.3 why that's really important, but I can actually figure out, reason through what the reference angles are, given the reference angle, finding the trig ratios for the reference angle. Okay, now, this, it's kind of interesting to point out here, and you are going to see it in a second. You're going to find the R value by the Pythagorean theorem, which is basically the hypotenuse given the reference angle. Now, given the hypotenuse in the two sides, you could figure out what sine, cosine, and tangent are, okay? They say, here's a formula. Tangent is always y over x, cosine is x over r, sine is y over r. I say, let's just figure out what it is. Now, these are going to be the most difficult problems probably for you guys, definitely within this section. So here's my suggestion for you guys. Plot the point. -6, +9. Okay. 1, 2, 3, 4, 5, 6. Wow, that's really equally spaced. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so just guesstimate where it's going to be. So here's my coordinate. There's P, right? Okay, now what's my R value? My R value is the actual distance there. Okay. So my suggestion to you is not my suggestion. Here's how to solve it. Set yourself up with a right triangle. Okay. What is this distance in here? -6. What is this distance here? 9. How do I find R? Pythagorean theorem. -6 squared plus 9 squared is equal to R squared. So 36 plus 81 is going to be my R squared. So what would that be? 117? If I go to square root that is not perfect square. Does that have any perfect square factors? Divide by 3. Yeah. Okay. So this would be 117 is equal to R squared. So let's reduce it down because it would obviously be the square root of 117. So this would be, look, I think it just said 3 and 39 there, right? Yeah. And then that breaks down to 3 and 13. So this turns into 3 radical 13 when I break it down. That's my R value, 3 radical 13. And now at this point, you're just finding, well, that is a very poorly drawn triangle. At this point, you're just finding the 6 trig ratios for this triangle, 9, -6, and 3 radical 13, right? Now, where does theta come in? Well, theta is actually your reference angle, this angle down here, okay? So here's what we could do. Oops, I scrolled a little too far. We're going to find sine theta, we're going to find cosine theta, we're going to find tangent theta. Once we do that, we're going to find cosecant theta, we're going to find secant theta, we're going to find cotangent theta. Ooh, cotangent theta. Sorry. I'm going to rewrite that. Cotangent theta. That's not much better. All right, so sine theta, opposite, 9 over hypotenuse 3 radical 13. 9 over 3 radical 13. Well, that's 3 over radical 13. Rationalize 3 radical 13 over 13. Okay. Cosine theta, adjacent over hypotenuse. So it's negative 6 over radical 13 over 3 radical 13. So this would be 6 divided by 3 is 2 over radical 13. So that means it's 2 radical 13 over 13. And then tangent theta is 9 over negative 6, opposite over adjacent, which reduces down into negative 3/2. Now, cosecant theta, it's the reciprocal of sine theta, right? So I'm going to go right in here, okay, because I don't have to re-rationalize. I'm going to say flip that guy. So radical 13 over 3. I'm going to flip this guy to get secant theta, which is radical 13 over 2. And then, well, it doesn't matter here, negative 2/3. There's my answer there. Okay, so sine and cosecant, cosine, secant, tangent, cotangent. Okay, let's do a couple more of those. Those are the more difficult ones, so we're going to do a couple of them. Okay. Negative 3, negative 6. It's in the third quadrant. Negative 3, 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay. Negative 3, negative 6. There's point P out there. Okay, now where's my reference angle? My reference angle is always made with the x-axis, so I'm making this triangle here. Reference angle right there. There's theta. Okay. Let's put in my dimensions. This was a negative 3. This is a negative 6. Let's figure out what my r value is. R squared is equal to negative 3 squared. Again, this is just Pythagorean, negative 6 squared. So r squared is equal to 9 plus 36. So r squared is equal to square root is 45. So r is equal to square root of 45. Now that 3 radical 5, because it would be 9 times 5. Okay. All right, now so sine theta, cosine theta, tangent theta. Now, sine theta is opposite over hypotenuse. Okay, so negative 6 over 3 radical 5, which is negative 2 over radical 5, which is negative 2 radical 5 over 5. Cosine theta, adjacent, negative 3 over 3 radical 5. So that would be negative 1 over radical 5, or just negative radical 5 over 5. And then tangent is opposite over adjacent, so negative 6 over negative 3, which is just 2. Now, cosecant theta relates directly to sine theta, so just flip this one here. So that would be radical 5 over negative 2. No need to rationalize again. Secant, oh, I forgot my CSC. Secant theta is going to be, take this and flip it. So radical 5 over negative 1. If you wanted to, just negative radical 5. And then cotangent theta gets me 1 over 2. Instead of 2 over 1, 1 over 2. Okay, those are my answers there. Let's do one more of those. Okay, 1 comma negative 1. 1 comma negative 1. Fourth quadrant there. Here's my point P. Here is my right triangle. Okay, so this is 1 and negative 1. Here's my right triangle. So that means my r value is going to be 1 squared plus negative 1 squared. So r squared is equal to 1 plus 1. So r is equal to 2. So r is equal to the square root of 2. Now, at this point, I know this is square root of 2, so I can say, and again, this is my reference angle, so there's my theta. Sine theta is equal to opposite, negative 1 over radical 2. Rationalize the denominator, negative radical 2 over 2. Cosine theta adjacent, 1 over radical 2. Same thing, just radical 2 over 2 in this case. And then tangent theta is equal to opposite over adjacent, or negative 1. Cosecant theta is equal to the reciprocal here. Radical 2 over negative 1, or just negative radical 2. Secant theta, let's go here and rationalize there. Or not rationalize, flip it there. Reciprocal there. Just radical 2. And then the cotangent theta is equal to just negative 1. It's the same thing, right? Because if I flip negative 1, I get negative 1. Okay. Whew, that was a lot. That was a lot of problems there. Hope we're all having a good day. See you, everybody.